Okay. If you hit Control-Enter, to go to full screen. So I got the infected machine booted up here. I just started the camera. So the infected machine takes a long time to boot, and now I'm going to run Process Explorer on the infected machine. Now I'm not going to do everything. Well, I could do everything right the first time, and it would be less interesting. So I'm sort of going to do it in the more naive way. I'm going to deliberately miss some malware. But anyways, it started the Process Explorer here. I think everyone else has Process Explorer started on their infected machine by now. You can see a lot of processes running on the machine. Process Explorer says 47. It was 54 earlier. Malware likes to crash. I should probably just reboot the machine, but it'll take too long. The purple processes are processes that Process Explorer thinks are packed. And so the way it tells if they're packed or not is it looks at the executable header that's running in memory, the PE header running in memory, and compares it to the executable on disk. And if there's a mismatch in sizes or well, if there's a mismatch at all, then it says, well, you know, the executable that's running in memory doesn't really match what's on disk, so it was changed in some way, so it's probably a packer. So purple usually indicates something bad. Well, it indicates a packer, and the packer usually indicates something bad. You can find legitimate software that is packed. There's quite a bit of it, actually. So it doesn't necessarily mean kill this. It just means, you know, look at this with a lot more suspicion than purple. And so we have, the other thing that's interesting is that Process Explorer shows us a process tree. So if we look at this win init process, then the processes that are directly under it in the tree, the services.exe, it means win init.exe spawned services.exe. And then we'll see SVC hosts underneath services.exe. It means services.exe spawned those SVC host processes. So when you see a process named system under this SVC host, it means this SVC host spawned that process. Or when you see this ibsvc.exe, it means that services spawned this process. Or when you see ntos.exe, it means winlogon.exe spawned it. And so that can sometimes give you an indication if this is malware, but this spawned it, then there's probably something bad. This is either bad or there's something bad running in it that's causing that to be spawned. Usually, when you see something bad under the parent, it implicates the parent as also being bad. But it only goes one level. It doesn't necessarily indicate that that parent is bad. And then, since Explorer.exe is the start menu and user interface that you browse through graphically to double click on stuff, when we launched Process Explorer, that we told, by double clicking on Process Explorer, we told Explorer.exe to launch Process Explorer for us. So we see Process Explorer underneath Explorer.exe. We see several things underneath Explorer.exe. There's lots of ways to get Explorer to launch stuff for you. One of the ways is double clicking on it. There's a bunch of different registry keys that you can get Explorer.exe to launch stuff for you. And the other way is, you know, to actually run DLLs instead of Explorer.exe that do things. And then when you see these processes out here, that's nhsio.exe, when you see these processes and they don't have a parent, it means that their parent died. So when your parent, whenever a parent spawns you, if your parent goes away, you don't go up to that parent's parent. You don't go up the tree. You just break off and you're your own little branch down at the bottom here. So we have no idea what spawned to this nhsio thing. And in fact, a number of times, malware will be spawned by Explorer.exe. It will respawn itself, and then it will go away, and then it'll break it off for whatever reason, maybe just to hide who spawned it or something like that. So there wasn't really any doubt that this machine is compromised. Looking at it in Process Explorer sort of confirms it. I mean, it's got a bunch of crap running. You may or may not be familiar with sort of the old classics like NTOS, Forbu, some of the more common malware that people have seen probably over the last several years. And so when I ran Process Explorer, I just double-clicked on it. I didn't run it with the UAC prompt. So when I click on something like Explorer.exe, I'm able to see the DLLs, and when I double-click on it, I'm able to see the threads. But there are other processes, MSDTSC, some Windows service, Microsoft Distributed Transaction Coordinator or something like that, some service. When I click on it, I can't see the DLLs, and when I double-click on it, I can't see the threads. Or I can see some threads, but I see threads that I don't have an address to. So I see a thread ID 240, but I don't have any information about where it's running. Now, again, this is a Process Explorer essentially lying to you. I personally think that this is a deficiency in Process Explorer. It should tell you access denied. You shouldn't say, oh, it's running at 0, because that doesn't make any sense. Or it should indicate something about you don't have a privilege, you don't have permission, or there was an error retrieving that data or something like that. But instead, it just defaults to 0. So this just means that we need to rerun Process Explorer as administrator. You can just go to File, Show Detailed Processes. We'll get the UAC prompt. Process Explorer will respawn. And you can tell Process Explorer respawned itself because now Process Explorer is no longer under Explorer.exe. See, it respawned itself. And then the original went away, and so now we've lost the child-parent hierarchy, so we no longer see it on Explorer, we see it all by itself. It's because we launched it under Explorer, then it respawned itself, and then the old one went away, and we just dropped off into this little branch, that broken off branch. Now we're running it with a higher privilege level. Now we should be able to access the services. So if we click on MSDTC, now we can see the DLLs that are, the DLLs that are loaded into it. And when we double-click on it, we should be able to see the threads. And now that thread 240 will actually see, instead of a 0 address, we'll actually see that it was at the MSDTC tm.dll. The bang, and then a name is just a function name, so it looks up in the symbol table, and then it says this is, it's at the main DTC main ext plus, and then the plus is the actual offset. And so this is some export function inside of this DLL, and it's running at that exported function some offset into that exported function. It just means that where it is in that DLL, where it's running. Okay, so now that we're running in a higher privilege mode, we should be able to run on, click on Process Explorer itself, and we don't see anything suspicious loaded into Process Explorer. This very, very, very cursory scroll through. We don't see anything suspicious running in Process Explorer. There are some processes here. Let's click on this 0R, this one right here, the 0R3BA 9R, whatever this thing is, random name. We'll click on it. We're going to see, we see some packed DLL running in it. We see this NOD32 from ESET running in it. So we see some additional things running in it. We see itself running in it. This is really weird. It manages to load itself and then put itself in its address space. Who knows why it does that? Goes to show that this particular piece of malware is packaged in some way where it can support running itself as a DLL in addition to an executable, or running itself in some other process's address space. So this is probably some relatively sophisticated malware, so a relatively good programmer or set of programmers. So I'm just sort of taking a survey of what's running on the system. Click on the system. This is going to give us the kernel. This is a summary of all the kernel objects. It's going to take a long time to load because this machine's so damn slow. Still loading. There we go. Okay, so that's probably bad right there. Some random named thing .sys. That's probably bad. And interestingly, there's a lot of other stuff loaded in here that doesn't have company names properly, like HTTP and error virtual driver and insecurity reg, which is unusual. I don't know. I would call it suspicious, but I wouldn't say it's a huge problem just yet. So the only thing that's jumping out at me is probably really bad is this. Here we have another process named system running under an SVC host. The path is C:\system. I doubt that that even exists. It doesn't have an extension to it. It's kind of weird. So that's definitely not the system process that summarizes the kernel. That's malware going, I'm just going to name myself system and hope no one notices. When I double click on it, it has 3 threads. One of them is the Visual Studio runtime, the Microsoft Visual C runtime. So basically that thread is not malicious. That thread is fine. And then it has, the system itself is running has a thread running, and then it has the DLL running in it, qm_dkl.dll. The export point is paste. Who knows what that means? And so we can see that DLL loaded into it right there. So I would say that this DLL is probably bad. I would also say this system is definitely bad. Forboot is definitely bad. NTOS is definitely bad. There's a bunch of definitely bad stuff running on this machine. So let's go over to, let's run Autoruns in addition to Process Explorer. So this is back on the resource kit. In the forensic resource kit, sysinternals directory, go to Autoruns and run autoruns.exe. Actually, we should just stop screwing around, and instead of running it just by double-clicking on it, you can actually run it as the administrator. So file run as administrator, or you can right-click on it and go run as administrator. Either one will work, but we need to get a UAC prompt. We need to run it with some higher privileges. It's going to take a while to scan it. Autoruns, if you're not familiar with Autoruns, what it does is it has a list of a whole bunch of ways that executables can start with Windows. Some of them are registry locations. Some of them are file locations, such as the start menu, startup directory to auto start, and drivers, and you can see a bunch of tabs. WinSock providers, Internet Explorer, scheduled tasks, and services. Different ways that stuff can start automatically. Scans them all, and gives you a long list of all the stuff that's probably starting automatically or could be starting automatically with Windows. And then if you go to Options, go to Options, Filter Options. Here we go. Autoruns has been updated, so it's no longer in the same location. I have checked the verified code signatures and the hide Microsoft entries. What verified code signatures basically means is that when you have this executable structure where you have the MZ stub header and you have the PE header, text, reload, whatever, you have a whole bunch of different sections. You can put a signature down at the bottom of the executable, an SSL certificate and a signature, that essentially it's a cryptographic signature of the executable that Microsoft has signed. And so you can reopen up the executable, run the hash of the entire thing, check the signature, check the signature on the hash, and check to see the certificate is actually signed by Microsoft. And you can say, yes, indeed, Microsoft signed this executable, and it all matches up, so it probably hasn't been altered. And so if you do that, if you verify the code signatures, it adds a whole bunch of additional CPU time because it has to go and open all these things and verify the code signatures. But it'll tell you this came from Microsoft and it hasn't been altered. And then if you choose hide Microsoft entries, then all of the stuff, where the signature validates, just disappears. And so it gets rid of a whole bunch of stuff that you just don't want to look at. Now, so here we can see like the Sun Java Update Scheduler is the name. The icon for this executable is either a white box or a transparent box. We can't really tell. So it's the Sun Java Update Scheduler. The description is OpenOffice Writer, so we have an inconsistency. The bad guys are just incredibly stupid. They don't even bother to check half this crap. And then it has a publisher, OpenOffice.org, did not verify. So the signature did not verify. It either didn't have a signature or the signature didn't verify. And the location is c:\program data /svc host. So you would think that if they were going to do a good job and they wanted to do the Sun Java update scheduler, then this would say something like Sun Java runtime or Sun Java update. And you know, even though the signature wouldn't verify, it would say something like Sun Microsystems Incorporated. And maybe it would be located at c:\program files /sun /java /update / they don't even, the bad guys are just dumb. They don't even try half the time to make their stuff look good. So that's probably bad. Shop at home, the select rebates, this is essentially legitimate malware. It's adware. You have 1,200 and some odd coupons, and this is a browser plugin. It has a legitimate code signature, so it's legitimately signed by the shop at home folks, and it's bad. I mean, it's not like terrible, but it's definitely bad. I'm hesitant to call it malware. It's sort of adware, spyware, whatever you want to call it. And you have a whole bunch of other stuff, including something called I want this BHL. You don't want this. And it also has a verified signature from Amazing Apps. And this is another piece of spyware that runs in your browser sort of semi-legitimately with some end-user license agreement that I'm sure that you agreed to at some point that said, we're allowed to do anything we want, sell all your data, and give you all these wonderful offers, and you have no recourse or legal repercussions against us. We have some services. We have this updater service. We have, so if you were wondering, if we go over to Process Explorer here, we see this iubsvc.exe, an install brain installer from install brain. And it was underneath the services.exe executable, and it looks packed. So that would indicate that services.exe started it. And that would oftentimes indicate that services.exe is bad or has some bad code running in it or something like that. But we can see, based on looking at Autoruns, we can see how that happened. We can see that it is installed as a service. It's installed as a service, and so services.exe literally just did its legitimate job. It checked the service registry keys. It said, I have this service. I'm going to go and start this executable. It did what it was supposed to do. So in this case, it didn't necessarily indicate something really bad happened. Then we have some really strange thing going on here. We have so Process Explorer colors in yellow anything where it can't find the file. And we have a whole bunch of legitimate drivers, and Autoruns, can't find the file. If these files really weren't here, a large number of these services are basically absolutely required to boot this machine. If the files really weren't there, this machine just wouldn't even be booted. So this probably indicates some sort of rootkit is hiding files on the machine. So let's go take a look. So where are they supposed to be located? They're supposed to be in System32 drivers. So c:\windows /system32 /drivers. And so what is the first file that it says it can't find for us? So it can't find the ntfs.sys file. So can we find ntfs.sys? ND, NE, NP, ntfs.sys is right there. So Autoruns says it can't find it, but we can clearly see it. Anyone have any hypotheses for why it is that we can see the file and Autoruns can't see the file? What's probably happening, and I haven't actually confirmed it, but what's probably happening is that there's a rootkit on the machine, and the rootkit knows that there's certain things that it should not hide from Explorer.exe, because then it would be really obvious. Because we're browsing, we're using Explorer.exe, so if it hid them from Explorer.exe, it would be really obvious that stuff would be hidden. But it can hide them from other processes and not have a problem. So one way, I haven't actually tried this, but one way to try to confirm this would be to take, and usually the whitelisting by executable name is literally just done by the executable name, it's not done by the path. So we can try something like copying Autoruns to the desktop, renaming Autoruns to Explorer. So now we're going to be running Explorer like you can see. Oh, we need to run it as an administrator. You don't have to actually follow along with this. This is just a hypothesis. Okay, so we still can't see any of those files. So it's really unknown why we can see them in Explorer, but Autoruns can't see them. It's possible that the API that Autoruns is using has been hooked in some way that's different than the Explorer.exe API. Or it's possible that maybe well, who knows what's going on here. But this typically, when you see an inconsistency like this, it typically indicates some sort of rootkit on the machine. So let me blow away the Autoruns directory here. So now let's just start nuking some malware on the machine. Get rid of as much as we possibly can. So we have Process Explorer running, and I'm going to get Autoruns running again. Okay, so now I'm just going to start killing processes that I know are malware. So I'm going to get rid of this for boot process. I'm just selecting and hitting. I'm going to kill this whole process tree. So this NHSIO, I'm going to right click and kill process tree. It's going to kill 3 processes. So we can see some stuff is coming back. My VM is going terribly slow. I figure yours is too. We have an SVC host sitting here. It's listed as blue. It's not under services. It's running as us, so it's running as the other PC / user person. Oh no, it's not. It is running under system. I don't know why it's listed as, or no, it's not listed as blue. It's listed as white. Sorry, my screen. I can't really see it from this angle. So let's take a look. I'm going to double click on it. So we can't see, like we have this thread 1060, but we don't have access to read the thread. So that's kind of suspicious. We can try killing the process. I don't know if that will allow permission to or not. Yeah, we were able to kill it. And if you've tried to kill the 0R3BA process yet, you're probably access denied. So it has prevented us from killing it in some way, even though we're running with the UAC elevated privileges, which again is going to indicate that it has some sort of rootkit level capability. It's probably running in the kernel, or it has some component running in the kernel that's intercepting any attempt to kill it and providing an access denied. So if we were running in the kernel ourselves, we could just blast it. But since we're not, we're going to have to work around this another way. So I've killed a bunch of processes. I obviously haven't killed all of the malware on the machine. So I'm going to Alt-Tab over here to Autoruns. And I'm going to start wiping out, obviously, bad stuff. Be careful here, because if you delete the wrong thing in Autoruns, say goodbye to this machine. So I'm going to get rid of the anti-OS, get rid of this XC whatever, NHSIO, Explorer.exe, EJ, disk32, load, edge, select. I'm going to leave the VMware stuff, it's legit. So I got an access denied, trying to delete the file out of the start menu startup directory. We'll worry about that later. Probably means it's running. So pf0f. Do we see pf0f running anywhere? One way to find out is we can use the search utility. So DLL handle, so we can search for pf0f, which I think is the name. pfof v.exe. Yep, and so it's running inside of the WWC EPY and the OR3VA. It's running inside both of those processes. So that's why we can't delete it, because it's running. So we can't delete a file that's running. So we'll worry about that later. Delete a bunch of these bad services in run registry queues. ThinkFrank stuff is legit. So notice in here in the services, there's this SIS NTGP filter. SIS is some ancient, probably out of business, defunct video card maker. And notice the signature says set to Microsoft Corporation, and the signature did not verify. This is clearly bogus, so I'm going to delete that. And this SIS RAID 2, that doesn't even make sense. SIS never made RAID controllers as far as I know. I'm going to delete that. It doesn't have a description, doesn't have a publisher. We have this VM bus. I'm going to leave, I don't want to delete too much stuff. I'm going to get rid of this KDHC. Okay. I'm going to get rid of the shop toolbar. So Autoruns should mostly look, I think, like this at some point. So after you're done deleting, you should get Autoruns mostly looking like this. Okay, I'm going to refresh Autoruns and tell it to rescan. So some stuff came back. So I suggest we reboot this machine at this point. It should be faster. Hopefully we didn't delete anything that we needed. If not, it'll do a restart. Sure.
When you're removing it from Autorun, is it actually physically removing the file too, or is it just making sure it doesn't run?
For when you see like the start menu startup thing,
Yeah.
that file's not, that's not a registry key, it's just a file in that location. So when you remove it there, it deletes the file. But when all the other entries that are registry keys, it's just deleting the registry key, it's not deleting the file itself. So when you're removing stuff via Autoruns, you're not actually wiping out the malware, you're just removing the little pointer that tells it to start. So even if you totally cleaned the machine by running Autoruns and wiping out all the registry entries, if you still ran an antivirus scan, you'd see the antivirus scan would say, oh, this machine's infected, this machine's infected, you know. And so sometimes students will do that. They'll be like, I took it to you and you cleaned my machine, and then I ran an antivirus scan and it was still infected. It's basically they don't know what they're talking about. They're just clueless. And the antivirus product also doesn't know what it's doing. Because the antivirus products very rarely correlate registry keys with files that, you know, they're just looking in this very narrow tunnel vision. They look at one file at a time, and they say, is this file bad or not? And they don't look in the broader context. So they don't look at like these multiple files exist together, therefore therefore it indicates bad. They don't look at registry keys, that sort of thing. And oftentimes, when antivirus is capable of detecting and cleaning a machine by deleting a file, they don't remove the registry keys that point at that file, and so they can leave the machine in a broken or inconsistent state. And then when that happens, the antivirus company has to enhance their cleaning to go, well, when we find this file, it means we need to look for these registry keys and remove them too. But antivirus is really pretty crappy software, you know. Okay, so the machine booted back up. We didn't get as many alerts or any of that crap. So I'm going to run Process Explorer again.
I'm getting a lot more pop-ups this time than I did last time.
I didn't have that.
Et ma ligne toujours is gone.
So this is all I have left running on this machine. If you have a lot more than this after rebooting, you just need to go and kill as many processes as you can, go to Autoruns, delete as much bad stuff as you can, and reboot. I intentionally left lots of stuff so that we would have more butterheads against on this boot. Okay, so let's go to Autoruns. Let's focus on one thing at a time. See if we can figure out what's going on. Oh, I'm gonna run Autoruns as an administrator. I already ran Process Explorer as an admin. Okay, so let's just pick one thing. I'm going to pick this Autoflow thing. It has two registry entries. It has registry entry in HK local machine software Microsoft Windows current version run and HK local machine software Microsoft Windows current version run once. There's two entries. They both point at something really strange. C:\users \appdata /local /temp ;autoflow.dll. Does anyone know what a colon in a path name means on Windows? Well, let's try browsing to it. See, Autoruns does not tell us file not found. Autoruns found that file. Yeah, it is an alternate data stream. Yeah, so let's go to, we can right click on it, we can go to jump to folder. And so we jump to the local folder. Now, if I right click on this C:\users \user \appdata /running /Microsoft quick whatever, if I jump to this folder, I end up in the quicks KZ folder, and I see the executable. See it right there. But when I do the same thing for the Autoflow entry, and I jump to folder, I end up in the local folder. I don't end up in the temp folder. And when I double click on temp, I don't see it in here. You just have to take my word. No matter how hard you look, you're not going to find it in here. The colon is an alternate data stream. And it indicates that the alternate data stream is literally on the temp folder. So this file is not contained in the temp folder. The file is sort of an alternate stream on the temp folder. And this is a feature of NTFS that Microsoft thought would be a good idea to put in back in the 90s when they thought that they were going to have to compete with Apple. And Apple, the HFS file system, the hierarchical file system, has, actually I think it was before HFS. Back in the ancient Mac days, files, executable files and that sort of thing weren't entirely all self-contained in one file. So like when I diagrammed the Windows executable and it had the MZ, P header text, it had resource sections. You know, the resource sections could contain thumbnails and images and whatever you want that's not really executable code, you can sort of stuff it into its own little section. Apple took a different approach back in the ancient Apple days, and they used what they called resource fork. And so this was like a second file that was attached to the first file. I've never used these systems, so I don't really know exactly how it looked. I think it probably looked like one file, and they sort of moved around as one file, but it was actually multiple files, and you could look at the alternate resource forks. And Microsoft thought that they were going to have to compete with Apple, and they thought that their services and servers and clients and everything like that were going to have to be compatible with Apple servers, and now Apple clients were going to have to be compatible with Microsoft servers. So they built this compatibility for resource forks into NTFS, and they did it via what they called, instead of a resource fork, they called it an alternate data stream. And Windows basically doesn't use this feature, or uses it very, very, very little. It's really an old legacy feature, and they've used it in enough places that they can't get rid of it. But they don't really talk about it either. They don't really have any way of showing it to you or anything like that. So there's this resource fork on the temp folder that contains a whole additional file, and there's no way to see it. The Explorer.exe does not give you any facility for looking at the alternate data streams on any file or any folder. And you can put an alternate data stream on anything. So the only limit is that there's only, if I recall correctly, based on testing I did years ago, you can have up to 4,096 alternate data streams on any particular file or folder. It's the only limitation. And they can be as large as they want. And if you check, like if you put the alternate data stream on a folder and you check what is the folder size, the size does not go into any sort of size computation or anything like that. For all intents and purposes, it's just invisible. You can't find it. But you can still access it. You can still, point a register key at it and run it, and it'll work just fine. You can put alternate data streams on a drive itself. So C:\\, or I don't know exactly what the syntax is, but I know you can do it because I've seen Malware do it. And you can put alternate data streams on folders, and you can put alternate data streams on files. You can't put an alternate data stream on an alternate data stream, so you can't have : something. So at least there are limitations to it. So there's basically no way that we're going to be able to go and delete this, because we could via cmd.exe, we could tell it to remove that file, and it would successfully do it if it weren't running, but it is running. And we can't see it, and so we could use a tool like LADS or ADS Explorer or some other alternate data stream searching tool to go and look at it or find it. Might as well. So let's go take a look at that. So I'm going to minimize Process Explorer. So on the resource kit, in the miscellaneous, we have file system, and there's an ADS browser utility on the resource kit. This allows us to see alternate data streams. So I'm going to go to computer, C drive. If I recall correctly, where was this located? It was in users, user, app data, local temp. Okay. Users, user, app data, local temp. When I click on temp,
1 second.
Yep.
Within miscellaneous file system.
File system, ADS browser.
Let's see. Oh, sorry.
Okay. when you do it and you click on the temp folder, you're going to see an alternate data stream on the temp folder. You're going to see the name, autoflow.dll. Stream ID is number 4. I don't really understand what the stream ID. It's probably some NTFS parameter. I don't really know. And stream attributes 0. I have no idea what that means. That's probably an additional NTFS feature. Data size. This is the size of the alternate data stream, so it's 113 kilobytes or so. Name size 36. I don't know what the name size is. It might be the full path name, like the C:\\. It might be like the full back path name might be 32 characters, but I'm not actually sure. You can try counting it. And then when I click on it, we can see the actual content. And check this out. We see MZ. That's the DOS stub. This program cannot be run in MS-DOS mode. So that's the MZ header. We're going to see a PE in here somewhere. PE, here's the start of the PE header right there. Then the PE header is a fixed size, and then we'll see a section .text. .rdata is read-only data, .data, .idata. So we're actually looking at an executable file on the alternate data stream. And if you spent as much time looking at Windows executables as I have, well, it's sort of familiar territory. There's some really interesting text in this DLL. I just love this. Check this out. I love this. This is really great. I did not put this in here. It's a whole bunch of asterisks. And then it says, if you read this, then this program was probably stolen from our laboratory. Author of this software is not responsible for any harm that may be caused by incompetent or malicious persons who use this software possibly running on your machine. Therefore, please remove this software as soon as possible. Click the Start menu, select Run, Enter, and then who knows why they did this. Maybe they thought they were going to cover themselves legally, or who knows. I don't know what's going on. It's a DLL. And the DLL has multiple entry points, or multiple export functions. This one has a init function that actually initializes it and installs it. It also has an uninstall function, and the uninstall function actually uninstalls it, which is kind of cool. So you can see, like, when you do a run DLL32 and you pass it a DLL name, comma, and then you pass it the exported function name and you pass it some parameters, you are actually run a DLL inside of an executable. You get to pick the entry point, everything like that. And so you can see that you're running the uninstall function, which is an exported function within this DLL. You could do this and it would uninstall it, and great, you know, they provided an uninstall feature and it actually works. Let's just pretend that they didn't provide us an uninstall function. We're going to go get it ourselves. So we'll go get it some other way. But anyways, this is a real gem of a find, I think. But so what we want to do, we're back in Autoruns here, and it has 2 entries. Let's delete them. And then we'll refresh. And they come right back. So this thing is checking its registry keys, and it's recreating them if you delete them. The other thing to try, instead of deleting an entry, sometimes malware doesn't, sometimes malware just checks to see if the entry exists. It doesn't actually check the contents of the entry. So the next thing to try is, possibly it's looking for this Autoflow entry. And we just delete out the text. And then we'll refresh. That didn't work. Okay? So it's actually checking the contents of the entry. The next most common thing that malware tries is it uses a string search. In C, it uses like stir or something. It checks for a string inside of the string. And they don't actually check that the string is like fully equal. They'll just check that what they are looking for is in it. And so you can add stuff to the end or to the beginning. So the next thing to try would be to add like a bunch of stuff to the beginning. Nope, it fixes that. And then the next thing to try would be to add a bunch of stuff to the end. then fixes that. Okay. So this malware knows what it's doing. You know, it actually checks everything properly. You'd be surprised how much malware you can defeat that's fixing its registry keys, but just adding stuff to the beginning or end. And then it finds what it's looking for, and Windows finds something else, and it no longer runs. I mean, malware authors really, they don't debug their software at all. They don't think about how people attack this. So we're going to have to go after this some other way. So we already know that if we delete the registry keys, they come back. We already know if we change the registry keys, they come back, they get fixed. So now's time to actually kill Autoflow, the DLL, or the thread everywhere that we can, so that it's no longer running and it can't fix itself. So now we need to take sort of a survey of where it's running. So one way we can do it is we can do the search utility. We can type in Autoflow DLL, and boy, oh boy, it's running on a lot of things. Notice all the things that it's running in are all blue processes, though. They're all our own processes. Okay? So let's start killing all our blue processes. Don't kill Autoruns, and don't kill Process Explorer. Fortunately, it's not actually running in Autoruns or Process Explorer, and the reason it's not running in either one of those, or it shouldn't be, but the reason it's not is because they were run as an administrator, and Autoflow is not running as an administrator, so it doesn't have the permission to access a UAC program. And so if it is running in Process Explorer and Autoruns, you need to restart those programs as an administrator. You can go file run as administrator. So we can use the search function again and find Autoflow. It's running in NHSIO, and it's running in this WWCEPY. This is a problem. This is a problem in that we know that these things respawn themselves. So there's a couple ways we could try going at this. Way number one is that we can go into these and we can kill the thread. So let me show you how to do that. So even though the DLL is loaded into memory, into their memory, that doesn't mean well, I can't even find it. So there we go. So I'm double clicking on these and looking at the threads. And I see two of them with the autoflow.dll thread. The two NHSIO ones have the autoflow, and then the top one doesn't. And the WWCEPY doesn't. Okay? So what I'm going to do is I'm going to go to NHSIO and kill this thread. And that sucks. When I kill the thread, just comes right back. So not only is it checking to see if it's loaded in the DLL, or if the DLL is loaded into the process, it's actually checking to see that the thread is running, which is also unusual. Most malware only checks to see if the DLL is loaded into the process. They don't actually, doesn't actually check to see that the thread's running. So the other option that we have is that because there's only two copies of this thing running, if we can kill them both at the same time. So basically what's happening is when I kill the thread in this one, the thread in this one spawns it. And when I kill the thread in this one, the thread, they're spawning each other. If I can kill them at the same time, then it no longer can spawn itself. And so the way to do that is we can just right click on this, we can choose kill process tree. That should nuke all four of those processes all at once. Not only that, when I nuked all four of those processes, they didn't respawn themselves. Because we inadvertently also killed everything that was respawning them, all those blue processes that were respawning them.
What if you can't see it in your threads?
Yeah, it wasn't showing up in my threads either.
I had to check all four of them.
I checked, yeah, I went through all of them. I even, like, I matched up with the process ID on the Autoflow, it showed the process ID of the specific one it was loaded.
When you do the
And then
search-
I went over there, it didn't.
Okay, well then go Alt-Tab over to Autoruns and delete the registry key and see if it comes back.
Mine comes out this way. 'Cause I have this one up here. I have no permission to kill it.
Yeah, I'm just kidding.
So like, I kill these, it pops up instead of trying to
Just
just
keep
there.
one more episode right here, trying to kill the tree here.
Yeah. You see, there's the same thing. See, mine starts showing up underneath here. Mine also.
So now when I went and deleted the Autoflow registry keys,
Brought it up under here.
and I
Mine
rescan,
went and bought it.
and the registry keys are gone now, for me.
Yeah, yeah.
We're dealing with malware here, and malware is not going to necessarily be consistent. It could have crashed, it could be buggy, it could be running in different conditions.
So I can just highlight all of them.
Oh, you can't do that.
If you do the search, do you see any processes or executables that's running in other than the WWC EPY or the NHSIO? Go kill those. Which ones are they?
2 Explorer.exe, 1 SVC host.exe, 1 DWM.exe, and 1 VMware chair.exe.
Kill all
It's
those.
like it's reinstalling it or
It's a bugger. Yeah,
I got a critical error, but then everything
The
died.
parameter is incorrect.
I mean, as far as the processes that I've been trying to kill.
I can't look upside down. I gotta come around here.
Oh, dang it.
So you should kill all those blue processes. Oh, so here's part of the problem. You need to run. You go to File and go to Run as. Oh, you're already an administrator. Okay, perfect. You kill Explorer. Oh, because you right-clicked on it and it shows Run as administrator
Yeah.
instead of Explorer. So kill Explorer, kill VMware, kill Internet Explorer. Just kill everything. Everything. Would you? Oh, you killed the process tree.
Don't want to do
You
that.
right-clicked on Explorer and you killed the process tree, right?
Yeah.
Yeah, that's the one.
Well, you were running underneath Explorer, so you killed yourself.
Oh, great.
Yeah, so you're gonna have to rerun Process Explorer as administrator. If you don't have, oh, you didn't have to reboot actually. You could have hit
It just did it.
You could have hit Control Shift Escape.
It just rebooted itself.
Okay.
Done. See if it comes back up.
Not yet, anyway.
So if I go back here to, see, this one, my kill is here. Here's the auto right here. Look at this, search that. These ones I can probably get.
Okay, well let's all tab over to Process Explorer. Okay, so you need to get rid of the VM. You need to get rid of all the blue processes. So you have all the VM, yeah, because it's running inside of already. So you're going to get rid of anything that is running on. So get rid of the DWM, get rid of the system, get rid of everything that's below the process. Well, except for Process Explorer and Autoruns.
Oh, it just came back.
Okay.
It's just came
This one
back.
won't let me.
Yeah, if the 0R, whatever, if you don't have permission, just leave it.
But all the other.
Yeah.
Then it brings back. What's this weird WER fault finding?
Okay, we only have 15 minutes left, so we're going to need to accelerate the killing process here. So make sure that Autoruns and Process Explorer are running as administrator. So if they aren't, then Alt-Tab each one, go File, Run as Administrator, Show Processes from all users, and make sure that they're running under a UAC. They're running higher privileges via UAC. Then kill all blue processes. That includes VMware, it includes DWM, it includes Explorer.exe. Kill all blue processes except for Autoruns and Process Explorer. That should get rid of everything that could have Autoflow or some of the other bad stuff loaded in it. The only thing that you can't kill is the WWC EPY and the NHSIO because they constantly respawn themselves. But the things that are responding them are those blue processes. There are DLLs loaded in those blue processes that are responding them. So once you kill all those blue processes, because we're going after Autoflow, we can also go after the WWC EPY and the NHSIO. Yes, sir?
So In this case, one of the blue processes that keeps respawning all those things is the explorer.exe.
Yeah, kill explorer.exe.
It's the one that I'm in.
Yeah.
But don't kill the process tree.
I killed it.
Okay.
Don't kill the
Just
process
the
tree, just
process.
kill it.
Okay.
Yeah, if you kill the process tree, you wipe yourself out.
Gotcha.
Yeah.
Yeah.
Yeah. So I was able to kill it and then jump to the entries and delete the registry keys, and now they're not.
And they're not coming back.
No.
Perfect. But you have Autoruns running too, right?
Yeah.
Okay. So yeah, so we're
Refresh it.
Well, yes, we can alt tab over Autoruns, and I'm going to wipe out all the bad registry keys in Autoruns and hope that none of them come back. Yeah, I'm not going to touch any of these current. Well, I don't know. I'm a little bit skeptical. This npfs.sys. I'm a little bit skeptical whether or not this is because sometimes there's malware that hooks Autoruns and it basically prevent their. Let's try to refresh it, because sometimes, for whatever reason, bugging Autoruns or malware hooking Autoruns or something like that, it just can't verify the code signatures for whatever reason. And so like I just refreshed and now it finished, and now I don't see some of those problems. So sometimes you have to be kind of careful what you're deleting in Autoruns. I personally think that that's a bug in Autorun, but I'm not entirely sure.
Those red entries just keep coming back.
Which ones?
The Autoflow red entry.
Yeah, mine came back.
And
What? So let's take a look at Process Explorer.
Process Explorer, only things I have now are the NHSIO and the WWSETIs.
Okay, so the issue is, yeah, so the issue is you still have some threads with Autoflow running in some of the WHSIOs. So now you're going to have to, if you hit close that, then you have to double click on each one of those four.
This is what I was doing earlier.
And then
with
go
it
to
showing up
threads.
in the threads list.
Okay, so it's not there, so you have to go to the next one. And there it is. So kill that thread. Well, so we know that if we kill the thread, we spawn the thread.
Okay.
So that's not actually going to help us. So what we have to do is we have to kill the process tree, and it'll kill all four of them all at once. Okay, so notice they got, okay, but, cancel there. Did the Autoflow get respawned inside of them? So that's the question. Looks like the answer is no.
Okay,
So
awesome.
we wiped
Okay.
we wiped every, it has like this last foothold. It's running in these last few processes, and anytime we kill one without killing the other, they respawn each other. But if you're able to kill its last foothold all at the same time, then you've gotten rid of it, and then you can go and delete the registry keys because it's no longer running. What are the reasons why you have so many malicious processes still running? When I'm saying kill all the blue processes, I also meant all the bad ones, all the white ones and that sort of thing. So you have like the system process that's running under the SVC host there, you want to kill that. You have some of the DWM stuff, you have some other stuff that you're going to want to go kill too. So I've gotten to this machine to the point where this is the only thing that is coming back. This 0R whatever. And we know that the 0R, we know that we can't kill it. And then the only other bad thing that we know about is when we click on system and we sort by company name. Well, yeah, the only other bad thing we know about is just this random named something other than sys file. Now, we know that the 0R3BA, this random named executable, we know that it must have some help. It's got to have something in the kernel helping it, otherwise we should be able to kill it. Notice that when we click on it, we can't actually see much about it in general. So if we double click on it and go to threads, it has one thread, and we don't even have access to figure out, okay, so it has a few more threads, but we don't even have access for the main one, the 1260 thread, just 0x0, we don't know. So it almost certainly has something in the kernel helping it. And we already know that there is something bad in the kernel. It's this E4B0. So a reasonable hypothesis is that this sys file, this driver running in the kernel, and this 0R, reasonable hypothesis is that they're part of the same malware package. And then if we go and delete them both at the same time, so if we delete one or delete the other, then they'll probably fix each other. So if we go and delete both at the same time, we'll be good. I tried for a long time. I could not find a way to delete these within Windows. So I had to boot. Into this non-compromised environment to delete them. The good news is that by default in Windows 7, there is a little stub environment. So if you go and take a look at the partition on a Windows 7 image, you'll see like a 100 megabyte some odd partition in the front in the beginning. That's the system recovery partition, and then the remaining partition is your normal drive. So if we reboot this machine, if you press F8 while you're rebooting, you'll get the boot menu where you can do like safe mode or whatever. So if you could choose the repair your computer option, this is very much like booting BART PE off of a CD in the Windows XP days. This is a Windows pre-installation environment, only instead of it being on a CD that you boot off of, it's sitting on your hard drive and it's installed by default. The repair your computer is a terrible name. It should be some sort of like, they should say like recovery environment or something like that. It's a terrible name. But and this has some tools to automatically repair your machine. I've never seen them work. I have no idea what Microsoft was thinking when they decided to call it this and do these auto repair tools. Maybe there are problems that this can actually fix by default. So I'm going to go to the command prompt, and we know that there's a E whatever something in here, E4. Oh yeah. Here's the other thing. We're in the X drive, and the X drive is the pre-installation environment. And there's also a C drive. So we can do C:, and I don't know what the C drive is. I think that Windows just must have a C drive or something like that. So they made this little stub C drive that doesn't mean anything. There's also a D drive, and this is the C drive in normal Windows install. So this has all the stuff that we want. So now we're in the D drive. We can cd to Windows /system32/drivers, and then we do a dir, and we'll find this file. So now we should be able to delete this file. There it goes. Okay, and then the other thing we need to get rid of is this file.
Could you just copy that like a Control-C or something?
You select it automatically, and it'll automatically paste it to the copy of the clipboard, and you right-click and automatically paste it.
That's cool.
And then we're done. Reboot this machine. So it's basically free built-in BART PE, and it understands, or even Linux recovery disk or whatever, but it understands NTFS natively. You don't have to worry about creating any problems. You don't have to. Does the machine have a CD-ROM drive? Does the CD-ROM drive even work? Like all the problems that you had with like booting off of BART PE or off of a Linux CD or anything like that, you don't have with Windows 7. It's pretty convenient. I really wish that I could show you guys some badass technique for wiping out that file within Windows. In the Windows XP days, what I would have done is I would have used IceSort or Gmer or Arcane Hooker or something like that. I would have gotten my own foothold into the kernel, and I would have just started wiping out kernel threads or wiped out the files or whatever. Unfortunately, IceSort, Gmer, Zooter, Tuluka, Arcane Hooker, none of them work on Windows XP or Windows 7 Service Pack 1. So that sucks. But as soon as someone comes out with a really good anti-rootkit tool for Windows 7 that works on Service Pack 1, then I'll be back. I hate rebooting the machine back into a PE environment to delete an executable. Or I just, I much prefer to do it within Windows. I try to.
You have a method.
Yeah, I try to remove as much malware as possible before even rebooting. I like to just remove everything all at once, reboot the machine. That's the goal. So I know that the machine's not clean though, so this is good news here. I deliberately left something. We have 6 minutes. Hopefully I can show it to you. When you're just going in like blast malware as fast as possible mode, you almost always miss something. So you always want to do a sanity check. So I don't see anything bad. Let me rerun as a administrator here. So I don't see anything bad as processes. Click on Explorer. It'll take a while to load. The machine's still busy. Wait for Windows to be slow. Okay, so we've got this N thing. So that's probably not good. And so let's jump to that. Properties, Explorer. We don't even see it here, but that's probably bad. And is there anything else bad in here? Well, there's this. Does this look bad to people? This Diane Fig, NFD32, ESET. It's not yellow. It's based properly. Or at least it's based in a way that doesn't conflict. So let me run, let's check to make sure the machine has an IP address. Oh, one of the cool things about Windows 7, if you hit the Windows key, and then you get this little prompt where you can start typing. If you type in the thing that you want to run and you hit Control-Shift-Enter, you run it with UAC automatically. So you can do everything from the keyboard. You don't have to use the mouse much. Okay, I have an IP address, so let's launch Internet Explorer here. Okay, Internet Explorer is still totally screwed up, or at least the settings are all screwed up, so it's going to have options. Might as well reset a bunch of stuff. Restore advanced settings, reset, reset, reset. Close, close. Now let's relaunch Internet Explorer. Okay. Use recommended settings. And of course, close out tabs. It tells us Google's not responding, which is kind of weird. What I was hoping to show is that the search results often get hijacked. If you go and click on a link and it hijacks them, it sends you to some other weird page. But it doesn't always do it. It only does it on some search results and not even consistently. Anyways, I figure everyone's probably seen search hijacking before, where someone goes to Google and they search for something and then they click on it and then go to the right place. The way that is happening is that this dianfig.dlo is hijacking the search. This machine's really slow. So if I clicked on Internet Explorer here, and then look, dianfig is also inserted into Internet Explorer. So what's happening is that this is malware, and it's not showing up in Autoruns. The reason it's not showing up in Autoruns is that well, let me show you. Oops. So I'm going to search the registry for a reference to this DLL file, write it, find, gotta find the actual file name, DIANNFIG. Okay. Anyways, Explorer.exe has a huge set of registry entries in the registry. In HQ local machine system, ignore this control set thing. Current control set, session manager, appcert DLLs. So we have this appcert DLLs entry. And, well, when you search apps, it's using a Microsoft feature. I don't know what appcert DLLs means, but it's using some Microsoft feature that allows a DLL to be loaded into a process in some automated or automatic way. If you search for appcert DLLs in Google, you mostly find references to malware, because as far as I know, malware uses this feature far more than anyone legitimately uses it. Autoruns should have shown this to us. I don't know why it didn't. I personally think the Autoruns should have appcert DLLs, and it should say, hey, you know, there's something loading in there. We can try deleting it. Maybe it'll come back. Doesn't look like it came back. Let's kill Explorer. Let's kill so let's do a search. So it's in VM tools D, so we'll kill that process too. So now we killed all the processes that it was running in. We got rid of the appcert DLLs entry and hit F3. With the control set, there's a current control set. There's two control sets. I think they're related to. I think when you boot the machine, it picks one. I don't know how it picks it. And the changes you make to the drivers and the registry keys and that sort of thing only happen in one of them. And then when the machine fails for whatever reason, and you go into F8 and you choose like last known good configuration, I believe it switches you over to the other one. But you'll probably have to check some Microsoft knowledge base articles or some TechNet articles or something like that if you really want to understand the control sets. But you have the current control set, which is just a link to an alias to one of the control sets. And then, so you'll have, you know, current control set 001, current control set 002, sometimes you have 3, 4, 5, you can have a whole bunch of them. And they are basically parallel, but only one is active at any given time. And so when you're searching through the registry, you'll find entries in both. And again, so I'm searching, and I don't find any more entries to dianfig. So we've probably gotten rid of that. We're running out of time here. Yeah, we're 2 minutes over. But if I reboot this machine, I do believe that it will be completely clean, and that if you go and run Internet Explorer, you won't have any search hijacking. You won't see the dianfig injected in any processes, and that N thing that was yellow was actually related to the dianfig. So by getting rid of dianfig, we got rid of it. But we could just kill Explorer, kill all the processes that N thing is loaded in, and then we could go and delete the files. So that would get rid of it too. Yes, sir.
What if they had created a DNS hijack? Would this have removed it?
So if you actually check on this machine, I believe the DNS is hijacked. So if I rerun, we go to run cmd, and if we go to ipconfig/all, DNS is pointed to 85.355.116.132, which is a really super classic Ukrainian Telecom. Actually, the FBI runs that machine now. The FBI has taken all those machines down, and they're running their own DNS server there. But the thing is that DNS was hijacked by some malware that was run and set that setting on the machine. The malware is no longer running on the machine and constantly resetting that setting. So if your host file has been hijacked or your DNS entry has been hijacked, and this is a really cool thing is if you go to Google using this DNS server under certain, okay, so the reason you don't see it inside of this lab is that I'm intercepting all DNS traffic via the router that I have set up here. I'm intercepting, no matter where you try to send DNS traffic, I'm rerouting it via IP tables to the local DNS server on this machine. And then my local DNS server is doing the recursive query. If you took this machine outside of the network, and you'll be able to download these machines and you'll have the video, assuming that the video is still running. If you go to Google with this DNS server, they'll see that you looked up their name via this recursive server, and they will put a huge banner at the top of Google saying, your machine has been hijacked, your DNS setting has been hijacked, and they'll send you to Microsoft for information. I wish I could show that, but I have to intercept the DNS queries in this network. So the way to fix this is you literally just go to your DNS settings, and they're manually set, and you just do it automatically via DHCP, and it just solves the problem. And you'd only run into a problem with DNS hijacking if there's still malware on the machine that's still like resetting it. Right. And we wiped out all the malware on this machine. The same thing with host files and other stuff. I usually get rid of the malware first and then worry about the problems the malware created second. Because if you're trying to fix the DNS, it's like a chicken or the egg problem. Kill the chicken before you.